Hi guys, welcome to this quick recording related to homework assignment number 1. There was a question from one of you guys related to this homework. And from the discussion, I thought it's a good idea to share with you all of the things that were discussed in then, and actually a little bit more than that to help you with the homework. As a matter of fact, I also extended the assignment a little later. The homework has to do with two items actually that the question at least related to. And the two questions. First of all, the first one is about the solar eclipse. And for that, what you do is the first question. Okay, let me share with you the question so that you guys see. Is to determine the ratio of the sun's size, namely the diameter of the sun, versus the diameter of the moon, to the ratio of the two. Okay, and you have some information in here in this table, so you should be able to find that, namely the distance to, you need the distance to from the Earth to the sun. This is about 150 million kilometers. This number. You will also need the distance to the moon. The problem with that is the distance to the moon is in kilometers, 384,000 kilometers. So when you multiply by 1,000, it's going to be 384,000 kilometers. So either you make this one in meters by multiplying by another 1,000, or you change this one in kilometers by dividing by 1,000. And then you do the ratios. That's one thing. And then the other thing that you need to do the ratios with to compare this ratio, this number, 150 million kilometers divided by 384,000 kilometers, is to compare it to the distance between the Earth. I mean, this is the distance, of course. You compare it to the sizes of the two, namely the radius of the sun over the radius of the moon. And the radius of the moon is here, 1,738 kilometers. And the radius of the sun, its radius of the sun, 696 million meters. Again, you have the issue of meters and kilometers. Either you multiply this number by 1,000 and you divide this number, 696 million meters, by 1,738 million meters, or you convert this one to kilometers by dividing by 1,000, and in that case you're going to do 696,000 kilometers divided by 1,738 kilometers, and then you will see the ratios of the two. Okay, so this in a sense, so let me stop sharing and share with you another thing in here. If I open it, so let me share the OneNote. So this is basically what you have. You have the moon, you have the sun. Obviously, the sun is much, much bigger than the moon. You have the radius of the moon. You have the radius of the sun. You take the radius of the sun. This is 696,000 kilometers, divided by the radius of the moon, which is 1,738 kilometers. That is one thing. The other thing you need to compare to is the distance from the Earth to the moon. So we need the distance from the Earth to the moon. That is, what, 384,000 kilometers, 0.4, okay, kilometers. And you need the distance from the Earth to the sun. That is about 149 million kilometers, okay, 150 million kilometers. What you do in this case is, so this is the distance from the Earth to the sun. So what you do in this case is the distance from the Earth to the sun divided by the distance from the Earth to the moon. And you're going to find the number. So here you're going to find the number, here you're going to find the name, and compare the two numbers. Okay, that in a sense justifies the fact that the moon during a solar eclipse will cover entirely the sun. Had the moon been any smaller, if the radiuses of the moon any smaller, then it would not cover. That is, if the radius of the moon is any smaller, it would not cover the entire sun. Had the sun been any further, also the moon would not cover the sun during a solar eclipse. Had the moon been any bigger, it would cover more, and the solar eclipse will last a long time, okay? Because the sun will have to go behind it for a long time before it reappears again, okay? It's going to be completely covered, and you cannot see anything, complete darkness. Okay, so total eclipses will really be something to much worse than they are. Or if the sun is actually closer than, or the moon, then it's the same thing. The moon is closer, then the same thing in here in this case. Okay, it's going to be the same result. So that's the problem. The other one has to do with the Mayan, basically Mayan method of predicting the next solar eclipses, and it's based on the 6,585 and 8 hours. Sorry. So 6,585 days and 8 hours for the next solar eclipse when it's going to happen. So we know according to the problem, and again, let me share with you the problem so that you guys see it. Share is here, it's on the screen, and it's in this homework one. So again, it's this assignment here. A total solar eclipse occurs over Africa on August 2nd, 2027, based on the 6,585 day, 8-hour time between repetitions of similar eclipses. When and where will the next solar eclipse happen? So we're going to answer both questions, when and where. Well, probably it's much easier to answer the question where first, and then we're going to answer the question when. So let me go into share again. So here is the thing. Africa, North Africa, that's exactly what this thing is going to happen on August 2nd, 2027. Years from now, okay? We are in 2023, so in about 40 years from now. Okay, so it's going to be in North Africa on August 2nd. North Africa is on Greenwich time, basically, at least that region is on Greenwich time. So it's going to be on 0 hours, basically. If it's 0 hours, and then it's 8 hours later on this side, and it's 8 hours early on this side. Okay, I mean, whatever on this side is early, and this is later. This is west, this is east of Greenwich. Okay, now we are 8 hours exactly from Greenwich in our region. So that means it's exactly going to happen here in North America and Mexico. So that is when the next major, at least based on this method, the next Mexico, not Mexico, okay, the next solar eclipse is going to happen, okay, based on this method. So we know where. So that's the where. Now the when. So the when, remember, a year is 365 days and a quarter. Well, don't care about the quarter right now, and I will tell you why we don't care about it. It has to do with the leap years. The way we fix the quarter, every 4 years, quarter, we account for another 4 days. Okay, so for right now, we're going to say there are 365 days in a year, per year. Okay, but I need to know how many years is 6,585 days. So what I'm going to do in here, I'm going to divide that by 365 days. So that's going to give me how many years. Obviously, it's going to give me the number of years if it's exactly multiple of 365. But if there is a remainder, so it's going to be a number of years plus some. Okay, so I'm going to stop sharing. I'm going to do the math because we need to do 6,585 divided by 365. So I'm going to go. First of all, let me put the calculator in here. Calculator. And let me share the calculator. Share the calculator. So the calculator that I have in here has, we're going to take 6,585 and divide that number by 365 to find how many years that is. According to this calculator, it's 18 years and some change. 18 years and few days after that, okay? Well, at this point, I don't care about the few days, I'm going to find them. But I know it's 18 years from the year 2027 when this is going to happen. So I'm going to stop sharing. And I'm going to share again the calculations. So what this is telling me then is this is 18 years and some days. I'm going to find how many days they are, okay? So 18 years from 2027, 8 plus 7 is 15. 1 plus 2 plus 1, that's 4. And then 45. So we know there's going to be sometime in 2045. So that's according to the predictions. 18 years from 2027 is 2045. But we started from August 2nd. So we're going to go from August 2nd. August 2nd of that year, okay? We need to find how many exact days there is. So what we're going to do, we're going to take 18 and multiply it by 365. And that gives me, according to my calculator, 18 times 365. According to this calculator, is 6,570. Please verify these things. So this is short from the 6,585 days by 6,585. Deduct from it 6,570. Okay, 5 deduct from it 0, that's 5. 8 deduct from it 7, that's 1. 5 deduct from it 5, that's 0. 6 deduct from it, that's 0. So it's 15 days. Okay, 15 days from this day, from August 2nd, 2045. Add to it 15 days. However, remember the business about the quarter day, because it's not, the sun does not really go 365 days, 365 and quarter. So we need to fix that. How would we fix that? We're going to account for the leap year. So we start from the year 2027. That is not a leap year. So that is 365 days. So we know this is a 365 days year. The next year, 2028, is actually a leap year. So that is 366 days. So since we need to add another day for that leap year, we need to remove that day from this day. So we can't really say it's 15 days. We have to only go for 14 days because of the year 2028. Add 4 more years to that, that's going to put me at 2032. That too is 366. All of the other years are actually 365. So that means that for the year 2032, I need to remove another day because I have to add it to that year. So I'm going to be with 13 days. Same thing for the year 36, because I have to add 4 years to that. That is also leap year. So all of these are leap years. That means February is 29 days on that day, that year. So for 2036, that's going to reduce the number to 12. Okay. For the year 2040 also, that is a leap year also. And that's going to reduce the number of days to 11 because it is also leap year. 2044 is also leap year. So every time I add 4 years, I have going to do that. So it's 10 days. Of course, 2045 is not a leap year. First of all, it's an odd year. Okay. Okay. It doesn't have to be an odd year. 2029 is a leap year. 2030 is a leap year. 2031 is a leap year. It's a regular year. Leap year is 2028, but the regular year is 2029, 2030, 2031. 2032 is a leap year. 2033 is not. 2034 is not. 2035 is not. 2036 is, and so on and so forth. Okay, so we have to add 10 days actually to this date. So the next earthquake, according to this calculation, is on August. 10 days from the 2nd is 12 of the year 2045 in North America. Okay, so that's basically the answer to the question. If you don't believe me, what you got to do is actually go to any browser you have. I'm going to open a browser in here. I have Bing actually, so let me share with you. Share. And new tab. Share. Okay, so I'm going to say look for solar eclipse 2045. Okay. Actually, I can go through the map in here and see the solar eclipse, but the date is exactly how we predicted it, August 12th, 2045. Okay, and it's over North America, as you can clearly see from these images, how it's predicted, and so on and so forth. Obviously, even the one in 2027 is not located in one spot. It actually moves around the whole area. So is this one too, okay? So it's going to be a good thing to see in all of these regions in here. They're either with total solar eclipse or partial solar eclipse, depending on how far you are from the region where it's going to happen. I hope this video is helpful for you guys. If you miss the point of it, please go back to it and watch it again and make sure you understand the process and how this works. If you still have questions, please reach out to me so that we can make sure that you understand this, how to do this homework. And as I said before, I extended the assignment a week later so that you can submit it and do it right. Thank you.